Hello everybody, welcome to another stream. How are you doing? So last stream we started optimizing the tile binning shader because what was happening is when we made an ellipsoid full size of the screen or something like this, in the shaders, when it was trying to bin them in the shader code into screen tiles, which are 8x8 little tiles that are on invisibly on the screen, these guys were have an array of ellipsoids basically. So whenever you're trying to ray trace from a pixel from the camera's perspective, you can just pick up a little array of ellipsoids to check rather than every single ellipsoid in the scene. So what's happening is when it was full screen like this, a single thread was taking a single ellipsoid and iterating over every single screen tile. So we fixed that by deferring the operation a bit. So instead now we we go over all the ellipsoids in the scene, figure out which ones we want to render. Those ones go to a tile bin entry buffer or something like this, and it just has a range of tiles on the screen. So it's like that's just a single U32 basically. You can pack 4 8-bit integers into there, and we'll get a nice range of tiles this ellipsoid will span. Then it also has like a depth and like an object ID kind of thing. So I think that's like 12 bytes, but I couldn't pack it down anymore, so I've run it up to 16 bytes to see how that goes. It's somewhere. It's not really good to view it in that file, to be honest. Yeah. So I've used my encoding system so we can pack it all down and stuff. So this is the tile bin object. It's got the bit field where it's got the tile coordinates all packed. We've got to use 32-bit ints because it's on GPU. And depth object and some padding to pad it to some cache line alignment. But yeah, I don't know if this is a good idea or not. We'll see. So after we've emitted them into a buffer, we then run one of 5 shaders. And the job of this one is to splat them. There's a hyper optimized, optimized. It'll be hyper optimized later on. Shader which basically takes a single entry per thread group in this case. This is when you want to splat more than 256 objects. Sorry, the object 256 times or more. It basically takes an ellipsoid per thread group, and then it's got 256 threads, which will essentially we're just copying it at 200. We're copying it at a rate of 256 times per loop iteration. Just doing it does it at 256 threads, and it's copying the same object. So that means when it's copying a single object for the whole screen, it's doing 256 tile copies at once, or copying 256 tiles at once. So that is, yeah, it's got to check the logic again today just to make sure it's bug free. Yeah, it's not directly copying, it's got to change the sort key. So it stuffs the different tile index in the high bits of the sort key and the depth. So then we run a sorting pass after we've splattered the objects into some array somewhere. And then once they're sorted, they'll be sorted by tile, then sorted by depth. We'll have a nice bunch of arrays which vary for every single tile. Cool. So let's go ahead and implement the rest of these guys. So we've got one for 256 plus items, and we've got some for between 65 and 256, 17 and 64. So they're powers of 4, 5 and 16, and 1 to 4 objects. So we've got to write optimized shaders for each of these. So Right. Yeah, I guess let's get these out of the way, then we'll do the other side. Break that code. Before I copy this, because I'm sure I'll copy it, let's just double check it. So this is bin index 4. This is the object index. Local index. If we're the first thread within the thread group, go into here, and it's your job to extract out the data and put into LDS. So this is something we've got to change. But I think a lot of them are going to share this. So I think we can call it graphics file bin splat objects. It's a bit long. Screw it. I think multiple of these are going to use this one. Bit long though. Yeah, I made it a global because if not, passing it through function prototypes would have been difficult. Well, right, so what I would like to do, I think I want to load them out to some registers first. I need all of these, right? I must do since they're all... Yeah, I think I need all of them. Why they're in there in the first place, right? Obviously. Cool, so they're all a bunch of U32s, excellent. So all we need to do is take all this. And let's just load them out to some registers here. Gonna make the names shorter as well, so the code will be a bit easier to read. So everything with LDS dot we just replace. Still find. Cool. Whenever we can name these any better. That's the object. Depth, min x, min y. I guess I'll call it min tile. Tile chord min x. I'll do it. Probably a bit better. Cool. Right, so the first thread goes into here of the thread group, fishes out the object, decodes the min and max ranges for the tile coordinates. Calculates the tile coordinates. Sorry, tiles count the number of tiles that it spans. Allocates some slots where we end up copying the duplicated objects. So just bump allocates, get the base index, sort for later, store all the stuff we need for the future. Then after we exit this, we'll put a control barrier down so the rest of the threads will wait here while this is going on. It'll be a bit slow, but this is the way. Because this bit will be really fast. So then we've got 256 threads at a time, copying a single element each. So we copy those out of LDS across all the threads into VGP. What will they be in? Yeah, they'll probably be in an SGPR. Quite good. So we go over every single tile and skip in 256s. This is known as the base index, or a local index here, which is thread index basically. The local thread index. Give the relative insert index. Make sure that's less than the count. Yup. Yep. And then get the insert index. Essentially, we've got a 2D range between min and max tile coordinates. That's going to be, it's going to be like in a row major order, or as a 2D array basically. So we reconstruct sort of relative tile x and relative tile y coordinate from that. Take the minimum x and y of the actual top left tile or the bottom left tile, whichever one it is. Then add the relative x, and that'll get you our proper xy coordinate for the tile. Then we can reconstruct the proper tile index for the full screen worth of tiles, and then pack that into the high bits of the sort key. Yep. And then work out the proper insert index and put that out. Right, that seems perfectly fine. So yeah, I think there's some improvements we could make in the future. Like, I don't know if copying in, this is copying 256 plus objects. Sorry, copying the object 256 times or more. Well, technically it's 7, isn't it? But yeah. Oh, where we go? There we go. So I don't know if maybe it's better to actually spawn, in some cases, less threads and maybe, let's say 128. And then this loop will definitely have to go twice or more. Yeah, I think there could be less waves. The waves would be able to maybe there'll be less waves that just well, no, it should be okay actually. I think, yeah, this is a better way of doing it. Comment 256 the time. Yeah, great. So let's go ahead and move this around for a sec. LDS memory should probably go up here. So let's copy some of this back to the shader before. This is for doing 65 256. So what I need to do is copy that in and then change that to a 3 because it's in bucket 3. So it used to be local size of sorry, thread group size of 32. But since we're doing, so we did 256 still, and then that would say if you you'll do this, you'll have a bunch of waves that will start, and those will end up going to sleep and waiting. So they could possibly be, and we might have changed it to 128. Yeah, I don't know what is best. Or maybe 64 is the better one, because this would mean there'll be no wastage while this is going on. And then whenever we do these loops, the waves that go over, the waves that miss this fail here, they'll go around again. They'll end here as well, because this condition will fail. Then they'll exit right away. Yeah, so maybe Maybe it is better to use the lower bound number. I'm not sure. We'll see. The problem is this one's now 16. Or 17, sorry. So if you change it to 16, well, the wave size is not 16 anymore. So for these guys, we might get them to copy 2 objects per thread maybe. And then you could do 16. 64 could be done in 2 waves. Hmm. So I wonder what approach you could take out. So rather than doing 1 per thread group, you could say I've got like 4. You could take it the other approach, right? Rather than having 1 thread group per ellipsoid, you could then say it is, yeah, rather than these ones, 1 thread per ellipsoid, instead it's 1 thread per. Mm, per ellipsoid or something like this. Hmm. You'll let four threads per ellipsoid. Sorry, 4 ellipsoids per thread. So you would be like, well, you only need 2. 32. No, but if you did that, then this for loop wouldn't work. Oh, wait, sorry. Yeah, you'd have to do this sort of for loop again, wouldn't you, still? Oh, right. So we did this. Give me some ideas. So what we'll do is I think we'll say 1 dispatch group could get you get a couple of ellipsoids, and then if you did, you could say the first. I'll say we did 64 because that's the most you would ever get in this. The low bound was kind of like 17, so it was 16 we wanted to do, so it's 16 ellipsoids to copy at a time, but you can't do that. So, also duplicate the same ellipsoid 16 times. If you do that, your wave is going to be half occupied. So 16 of them will be inactive. We could just make it 32 and just leave it like that. Leave the code like that, but then hmm. Right, or could you do some sort of hybrid between the two? Where, say if you did 64, and you could say, um, so each thread group is four different ellipsoids in it. But then you'll be copying those into LDS memory. No, you won't need to do that anymore. Because they would all be in the same wave. So you might want to figure out what's the number of you could probably do some wave intrinsics to get the number of tiles to bump allocate basically and insert index. That could work. Between the high and the low one. Or you could use LDS to transfer it across and do it all together. That could also work. Right. Give me some ideas. The object ID will be this, and then plus some sort of like SV dispatch, oh, the local index divided by 2. Right, so this will be what's known as we'll call it the sort of wave object local index. It's going to be either 0, sorry, not divided by 2, divided by 16. Plus 1. No, so yeah, so this will be 0, 1. Wait a minute. That won't be a wave though, will it? Your wave thread index divided by 16. If it's less than 16, you get 0. 16 and above, you'll get 1. Right. Then this will be what's known as the ellipsoid base index. This will be the thread group object base index. Right. So the object you are trying to duplicate at least 16 times. So you would read the object out, read out its tile coordinate, get the number of tiles. You want to atomically add to LDS memory, which should have been initialized to 0, mind you. So we should probably say, well, if your local index dot x 0, 0 that for me, please. Then, yeah, do all this. So you want to know if you're the first thread within the object. So Boolean is object first thread. So you would be that if wave thread index. This is all because we don't have wave. Oh wait a minute. Yeah, it's quite dependent on wave 32. Oh. Yeah, you know what, we could worry about hyper optimizing it later. We can do this, but I don't know if it'll be a. Let's just make it 32 and just move on. If it becomes a problem, we can always optimize it later. Yep. So we're just going to do the same trick as the ones afterwards, but just do 32. So yeah, it's not. There might be some wastage, I guess, on the lower bound ones, but it's interesting. That should work. Right, so there's the 16 one and the 4 one. The 4 one's going to do a 2D. So if you have 4 times you meant to, if a ellipsoid spans 4 screen tiles, we just do a 2D array thing here. Maybe this might be better to make a 1D loop so you have less inactive lanes. Maybe. So we can look. So if you want to achieve that, you need to flatten this out. Well, you got the number of tiles, right? So you just need to reconstruct. It's the similar trick we've done here. Basically, it's like this. It adds more instructions, but maybe in the loop. But you might have less inactive lanes. So say like if you have, so in this case, you're getting 1 thread per ellipsoid, and then it's going to duplicate it, you know, 1 to 4 times. Yeah, because that's what that one's specifically designed for. Say if you have an ellipsoid which spans 2 tiles like that, and another one which spans 2 tiles like this. This is going to be active for the first 2 iterations, right? And then in the next while loop, it won't be active at all. You have an inactive lanes for this one thread, for this ellipsoid. This ellipsoid here will then be active. It'll be active for the. It depends which way you go, right? We do bottom left. So this for the first iteration. So yeah, first one of this, first one of this. Then on the next X iteration, it'll be inactive. Then in the next Y iteration, it will, and first X iteration again, it will be active when it tries to bin it in there. And then on the next loop, it'll be inactive. So you'll have, yeah, different. Yeah, you'll have different ones which are active and inactive. So the best way to solve it is if you flatten out. Hey there, Spectre, how's it going? Starman, how you doing? How are things? So I reckon what we can do is we can do the trick we did down here. Basically calculate the tiles count, which we did. Oh, already done it. Yes. So we're just going to do one for loop over all the tiles instead. Tiles count. And then we're going to simply go over all of those, but we've got to calculate an x and y. The way we did that is we got the relative xy from the... Where's the object width come from? Right. Object tile grid width. So that take that. Then construct a relative x, relative y. Where's the insert index? Right, so the insert index will just be tile and relative tile index, isn't it? Yes. Yep. So this would be like 0 to 0 to 4 at most, something like that. Then tile coordinate x, or reconstruct the proper xy coordinate in tile space. So these tiles are 8 by 8 pixels at the moment. There's the xy coordinate of that tile in tiles, right? Not pixels in tiles. Then we calculate the tile index by multiplying the y by the amount of tiles across the screen and add the x. That's the proper tile index, and then we stuff that in there. So we might get better occupancy doing it this way, but we've got some extra instructions being executed. So I don't know. Maybe we did something good there. So the next thing to make this shader better is this add here. Per thread it's per 32 entries. Sorry, each thread gets an ellipsoid that is trying to bin, right? Across these many tiles or whatever. Every thread is going to hit the same global variable and try an atomic add, and every thread group is also doing that. So at least you want to share this between all the threads within the wave. So realistically, what you want to do is probably a wave tiles count, where you do a wave active sum of the tiles, right? Then the first thread within the wave goes and does this. So there'll be what's known as an insert. This will be known as the base insert index. Then we'll simply say this is wave active min of itself. So we'll initialize it to U32 max. So the first wave is going to set its register to this, the sum of all of them. And then the rest of them will get it by taking a min with all the ones in the other threads, the other 32 threads, and pass it back to you. Then you've got to figure out, how do I get my insert index? Oh crap, how do you get it? We should have done a prefix sum. Wave tiles start index. Relative insert index. Yep. That'd be the prefix sum. So the prefix sum will add all of the tile counts across every single thread, but it returns to you all of the sums that happened before your thread. So it'll be base insert index plus the relative, and voila. Then we can keep doing the plus there. So that will at least help with the this global variable getting atomically added to 32 times more than it yeah, it should have. So another way we could optimize this, but we're not going any further because we really need to sort of from this point onwards actually do some testing before we just blindly do it. This could go up to a larger number, and then we can do this per thread group. So we could then do the atomic add once. So maybe you could do 256 ellipsoids, and then do this sort of like prefix something across a thread group. You know, this sum and prefix sum across a thread group. One thread across the whole thread group does this, and then the rest of them get their insert index again. We've done this in the past in one of the previous shaders. So this would then reduce the the amount of times this gets atomically added to by a bunch of different threads even more. But yeah, I don't. Yeah, we'll see how that goes later on. Forgive me for being late to the party. What's the purpose of binning here? Some kind of forward plus rendering thing. Yes. So I've got an ellipsoid-based renderer where we ray trace. So what happens is we I don't know what else I can do. But yeah, got an ellipsoid in the scene, and we basically ray trace render it by doing a bunch of rayverse ellipsoid things, but you could have a whole ton of ellipsoids in the scene, so rather than every pixel that fires a ray, checking every single ellipsoid in the scene, we bin them into screen tiles. So screen tiles appears to be the best approach to do this acceleration structure, but obviously it only works from the camera's perspective. Whenever we want to do any sort of like GI in the future or something else, we're going to need some other kind of acceleration structure. I'm still not sure if I want to do a BVH because I've done one about 4 times now, and I think the divergence is such a big problem. But there's still one more approach I could look into for the BVH, but just the complication in code and the divergence is just such a big cost that yeah, I don't know if I would like to do a BVH in the end. Yeah, such a rather interesting technique. I've never implemented a ray tracer, so I won't consider that. Yeah, screen space acceleration structure. Yeah. So I've tried it with like voxels as well. You know, Frustum voxels. That wasn't any better. So the way that I do it is that we get the ellipsoid, and so say if you have like a screen with like, you know, quite a lot of tiles, and you have like a big old ellipsoid that covers every single tile. Well, the optimization that we had to make was this original one was doing like a 2D loop per ellipsoid. The one thread had an ellipsoid, and it would try and do a 2D loop over every single tile and try and bin it into a tile. And that was really expensive because you could have some ellipsoids in the same wave, which are small. So these threads would be that did these four here would be inactive while the rest of them are binning for this guy, this big ellipsoid. So we've ended up like doing, going over all the ellipsoids, figuring out which ones we want to render. Those get put out to an array somewhere. And then from then on out, those ellipsoids get, they're binned into how many times they want to copy to different tiles. And then we've got different shaders for different workloads of copying, basically. This is what we're writing out here. So ones that want to do the full screen, those will get bundled together. Well, not full screen, but a large amount of copies. And then, yeah, those will go off and do their thing. What else? I don't want to say about that. Yeah, so it doesn't actually bin them into screen tiles at this point. What it does is it bins them into a big old buffer. Two big old buffers. One gets the what's known as the payload, where it stores the index to the object, so the ellipsoid, and the other one is the sorting information. This is the sort key. So it stores in the high bits. It stores the tile index, so we'll call it T index, and then T index, tile index, and in the low bits it stores the depth. And the beautiful thing is when you sort this, we use AMD's parallel sort on the GPU, so it sorts this whole array along with this array wherever the ones above it got in the other array, right, got sorted. So if this one moves to this index here, so will this entry as well, right? So that's pretty sweet. Then after that, you'd have two arrays, which are completely sorted by tile and by depth, meaning, back to this guy, whenever you cast array through the screen, you get the tile. It now has a linear array from front to back. So if I ray trace against this guy here and we get a hit, I don't need to check this one or this one, right? Unless this one is transparent. And it also allows me to do alpha blending front to back. So I do transparency that way too. It's not perfect when you have overlapping objects. If this center position is further ahead than this one will technically come first, right? But it's good enough. Yeah, that's the renderer so far. Yeah, so yeah, we don't have any off-screen objects or objects that are yeah, so it's only from the camera's perspective, right? If we want to shoot rays which are from the world, they've either got to be in. See, the problem is, right, because you're effectively getting like an infinite. Crying out loud, I pressed L. There we go. Your tile, imagine this is not a ray, but instead of the bounds for each tile, right? So this is one tile, right? What you're getting, so say if you have this sort of object in the world that you hit over or here or something, I don't know, here, and then you've got the surface and you'll then fire an array off there. If you just do this all in screen space, you would have then there's no depth information of where the tiles start, the ellipsoids start and end, so you'd have to iterate over all the ellipsoids that possibly intersected with this tile, right? And then does this ray intersect those? No, it doesn't. So then you can go to the next tile, right? This is where binning them into like Froxels might be better for this case. So we could do like Froxel based binning where we add some kind of like depth to the grid, right? So there's like a Froxel binning that we now do. And then that could get an even smaller list right, to look over when we have in-world rays. But then the problem with that one is that it doesn't work when you want to go outside the camera. So if we're going to be doing stuff like that, we might do a world space grid, maybe. But yeah, we'll see. Yeah. Of course, this is the other one. This is the let's copy this one actually. 5 to 16 objects. So this is at most what, a 4x4? Sorry, into 4x4 tiles. All right. Yeah. So either you have a one that happens to span like 3 tiles like that. Kind of rare. Possible, I guess. But yeah, we'll span 4 tiles, something like this. I think we'll just leave it as like a copy of the shader above. But the best thing about this one is that it's going to at least be 5 tiles to iterate over versus 16. So, sorry, versus including some of these small 1 to 4 tiles that they span. So I think we'll leave it like this. This is the semi-optimized splatting shaders. I've just got to finish up this one which sets up the arrays, sorry, the dispatch, because these are launched indirectly. So we've got to figure out in each bin, we've got a bunch of bins. There's the... So in order... There we go. So in order to call the correct splat shader and have a linear array, we've got 5 bins. Start, and the powers of 4. Going all the way up to... Yes, there's 5 bins. They're going up to 256 plus, so that's the 1024 one. So it's right. So yeah, these bins hold an object in each entry, and we need to yeah, they hold a few different things, right? They hold a this tile bin object in every entry. It has a range of tiles which they need to be splatted into. The object and the depth. That's all it has. And then the splat shaders run. So after we've emitted them into those different bins, we need to actually say, right, set up the dispatch indirect arguments so the splat shaders will all run the appropriate number of dispatches to copy those objects. So effectively the first 2, I think we can say some ideas. We can do an if statement. If, so the bin index would be bin index would be sv dispatch index. I think if it's less than or equal to 1, then it wants to do run out loud. Right. Cool. So the first two get one thread per ellipsoid. So we need to launch the number of objects divided by 32, which is the thread group size, rounded up. That's the number of groups we need to launch. Whereas the rest of them, they have one group per object and they copy many objects across multiple threads because they benefit from that. So I'm going to write in here one ellipsoid for each thread. Is copied one thread, one ellipsoid for each thread is given to each thread to copy as many times to make an entry for each tile it overlaps. One ellipsoid is given to each thread to make an entry for each tile it overlaps. Cool, same for this one. And then the rest of them, one thread group is given a single one ellipsoid to copy or to make an entry for each tile it overlaps, using all the threads in the thread group. Something like that. Same for that one and that one. Nice. Okay. I think that should be optimized there. So if we give it a run. Right, something failed. Shoot, I need to do .x. So we can look at the benchmarks. Last stream we figured out that, was it last stream or was it off stream? I think, yeah, I figured out that the profiling times are actually quite alright. We can trust those. Right, so 1150. Right. Yep. Let me see the other ones failed in it. And then this means we can make sure that the logic for the, or we can generalize the logic for the ellipsoid. All right, here we go. The code that goes over all the ellipsoids and then adds them to the different bins. Make sure that's all generalized a bit, so I can reuse this our binning code for the UI system we have. So, right. It's really hard to tell what's going on now. It's just so jumpy. I need to get that profiler written out so we can just use that. Just look at it on screen instead. Maybe we can get time to do that soon. But it seems to be running at 2 milliseconds, something like that. We could always print the timeout on... Oh, that's a bug. Not good. We're not launching enough threads there or something. Seems to not be happening here like this. So when it gets small enough, so we can figure out which one that is, we have a number of different printouts happening. Right. So, right, they're both in that third one, that 256 one. So 1 to 4 is the first, or 0, right? 5 to 6, 16, 17, 64. Yeah, and then that'll be 65 to 256. So that shader is causing that problem for some reason. This one. Why? I wonder. Um. mm, So it could be the launch parameters, maybe. No. They're okay. I think it's launching the correct number. Yeah, it's launching two. Yeah, we saw the number. It got printed out as two, one for each ellipsoid. So that's fine. So when it's running this, it fails for some reason. So it's the right hand side. Is that meaning that it's not? So we can go to that tile bin ellipsoid shader. Maybe we can still that debugging, viewing stuff. Tile bin ellipsoids. I think I removed it. Yeah, I removed the code, but no biggie because we can just write it again. It's not too hard. So I think there's this sort of like yeah, min and max one here. So what we can say is like if you're the first so it's draw 2D ABB min max. So with that we can do min point screen space, max point screen space, and depth of 0, border thickness of infinity. Wait, let's do 4 pixels. Then -1, so be white. We'll then just say, right, if you're the first ellipsoid, then do that, please. Cool. So, give that a go. We should see a nice bounding box drawn around our ellipsoid. So it's just dispatched in a later compute shader. Yes, it's quite big, right? So it's obviously not the best bounding box, but it does the job. So we get some extra spinning. It's because it's got that high field of view, right? So as you can tell, it's clipping on the inside of that thing still. Seems like there's some sort of round down thing happening. Or it's like a reverse. Yeah, it's like a round down thing. Right, so I don't think it's happening there. We could draw the tile. So there's like a max tile X, Y thing. So we could draw the max to the right tile by doing something like, well, if you take... So we'll leave that box drawing, but we'll also draw some kind of like... I think we use floats here, right? I think so. Yeah. So we'll do like a max. Let's call it start. I don't know. Words. So we could... What do we want to put in here? Equals what exactly? So tile min dot x multiplied by the width of a tile. Yep. And then the end is going to be basically this plus the it's going to be that plus another tile dim basically, and then if we draw that, we'll give it like a red color. Yeah. So that will just be bounds of a tile, and if we see that, then it means we should be... Oh, so if we see in the right place, then that logic should kind of be correct. Right, so we're seeing it at the bottom left for some reason. Bit weird. Hey, is the min greater than the max? Is that what I'm seeing? Might be the case. We could debug print those and find out. Um, do that just in case. Right, so it's start x. Well, I just want to do tile chord min.x. Hang on. Max x. Max y. Let's try that. Should tell us the coordinates. So if the min is greater than the max, then we probably got some logic which doesn't like that. We obviously should just correct the min and max to make sure they mean min and max. If not, incredibly wrong. So in that case, they're both 0. I don't know what was going on there. Bit bizarre. Wait, they're not floats. Don't be a wally. They are a bunch of D's. Right, so the answer is no, these are minimum and these are maximum. Okay. Hmm. Right. I'm just gonna take a quick few minute break and then we'll resume in a second. Right, BRB. Ah. Alright, welcome back everybody. So let's figure out what the crap is going on here. So why is the start and end? All right. Oh, I'm doing the min corner, isn't it? So it is going to be in the bottom left. Of course it is, right? Cool. So yeah, I was looking more about the right hand side, wasn't I? So actually, I was meant to say do the max one. Right. So that will. You want to be including that one. So it'd be cool. Right. So we should see a tile on the right hand side at the top. Ooh. Yeah, there we go. So it seems like it is fine, right? Every single place where this right hand side and top overlaps is where it goes. It never goes outside it, by the looks of it. That's the little screen tile. It's so small. Right, the tile is definitely moving along with the thing, but as you can tell, when it moves is when it sort of the this sort of bit that's being rubbed out is also moving as well. So right, but at least we are including that one. So we've got to figure out then. Okay, so um right, what could be go to the splat. It was the splat 256 one. That's the one that at least had the problem. Well, maybe they all had the problem. But we only saw it because the box got small enough for that one. So maybe he's doing a min take max plus one. It's inclusive, right? So we have to do the add one. And then you product it, that will get you the number of tiles. That seems legit. Is it copying to the right tiles though? That is the question. That is a good question. What we could do is say, well, if you're the first object drawn on the screen, that's going to be slow. But we did this in the past where we drew all of the tiles. But it'll be fine. Because my 2D drawing thing is not optimized. I need to tile bin that, and then it'll be optimized. Because it's done per pixel, goes over every single object. It's kind of slow. So yeah, say if we're gonna emit this many. So what I want to say is like, well, only run this code if it's actually way of saying it. Whereas I don't have tile dim. Where would you get tile dim? Right, you get it from a global. Cool. Right, so we really want to run this code if this is equal to 0, so it's the first ellipsoid, and if excuse me, so the tile index yes, it's bxy times right. Very good. So we'll do a bit of a color. I've got a thing called GPU, not try. Oh, if that try, then my keyboard's changed. GPU, nice color. Pass in some value. So the value we'll put in is like, probably rel insert index will do. Be unique enough. So they should all be colored differently. Nice. Let's give that a go. Oh, we also want to say, and if the number of tiles we want to insert is less than 256 or something like this. Oh, it'll only be in the 256 one, wouldn't it? Good. What's going on here? Oh, come on. Is this before the shade? Alright. I gotta forward declare it because it's implemented in the shader code itself. Oh, it seems like it doesn't cover it. It's hard to tell, but if I take a screenshot, we'll be able to see it. Wait a minute, I gotta get this. I think I missed it. Do it again. I think I did the same thing again. Let's open it up and see. No, it's hard to tell. Oh. I think I did it again just at the wrong time. Right, let's have a look at this one. Yes, I think you can maybe tell, but it's cut off here. That one's not rendering as well, maybe because it's just too many. Oh, that's questionable. Why is there any? Oh, we can see a bug in the code, can't we? So, as you can tell, the way we reconstruct the XY is actually a bit wrong. it's not actually in the right. There's either, yeah, I think it's a bit too little for some reason. Weird. Doesn't quite fill the whole thing. It's as if the last column or row is missing, or both. Some reason. It sums up with this logic. Right, so if you have a 2D, a range of the two 2D coordinates, and you get a range of in 2 dimensions, right? Um, it seems to be that last one, doesn't it? Which means then this, it's not all going into there, is it? So if I were to, no, we can't. Um, Found it. It's missing the last column. It's an inclusive range. I'm used to exclusive ranges, so I missed the +1, isn't it? Yeah, there's the bug. Right, we found it. Move back on with it. So this, I actually did this in a few places. Whoops. So just got to find all the places where we did it. So this one did it. And this one here. Neat. So all of them actually had the bug. Now if we run it, we shouldn't see that problem. If we move back, try and move it around, we don't see the end of it disappear anymore. Yeah. Oh. I think I saw something. Or there might be some other kind of glitch around here, maybe. I don't know. Should the language be 1 based? An convenient shortcut for the +1 and so if it's 1 based, does it mean you don't have to do a +1? So the reason why I do it as a min max, sorry, in inclusive is because I'm using the language minimum and maximum. And also when I do some packing, it means I can pack it down a bit easier too. So it actually fits properly into into bytes. So it includes a 256 file. So if it was 1 based, I think you still have the problem, right? Because everything would just be upped by 1 anyway, right? So the difference would still be the same, right? So say if something is 1 based, say if you got a range of 0 based, 0 and 5, then if it's 1 based, it would be 1 and 6, right? then the difference between those two numbers is both 5, right? So the problem doesn't go away. It goes away if it's exclusive. Right. I think we're in a good place there. Now I just want to generalize the code a bit. Um, for the so what we're going to done is we're going to made a nice generalized tile binning API. We can start the tile binning process. In between the start and end, we'll do a custom shader, which basically takes the objects you want to bin and emit them into the different bins. And then you run tile bin end, and it splats all the objects into the big old tile bin entry buffer, and then sorts them into the tiles and by depth, and then finds the start and end ranges where each tile's arrays start. And then after that, you've got a lovely set of arrays for each tile. And I can use it for more than just this ellipsoid rendering. I can port my UI rendering to this. I can make it so that my debug drawer uses this and it's not slow when it does so many objects. So it's got a lot of uses actually, more than I originally thought about. So the thing is, though, I've not generalized the code in. So this is the custom shader which you would write for each thing you want to bin. This one bins ellipsoids. I need to change the name of it a bit. So this one gets one thread group. Oh yeah, one thread gets an ellipsoid, and it literally just gets the screen bounding box for it from the local space bounding box of the ellipsoid. And it's a rough screen bounding box because you can't really get a good one too easily. You probably do some extra maths, but not my specialty. So you get your tile coordinate min max, and you right. This is the code I want to generalize. Something like this. It does some. It does some. I need to go over it again. Double check. But basically, we've got some sort of LDS memory. Yeah, so I think the main problem is I want to make sure that I'm not saying every thread atomically adds integers. All right. Let me describe what this does, this shader does. So we've got these different sized ellipsoids. Each thread gets an ellipsoid, gets the screen bounding box for the ellipsoid. Kind of rough. And then it goes, right, I've got to find how many tiles on the screen does this overlap, right? And it gets that number and gets the power of 4 bucket. So what power of 4 does that tile range fit into? Sorry, which one is it? There's like a span. The first power of 4 bucket is from 1 to 4. The next power of 4 bucket is from 5 to 16. And the next one is 17 to 64. So imagine if this is the 64 one. There's another big old array somewhere. They're actually split into 5 different arrays. We'll do 3 as an example here. So they're max allocated to 65k each. Ought to be good enough. That's the maximum number of entries we'll ever want to bin. This will go into this one because it's covers 64. Sorry. It's somewhere in between 17 and 64 tiles. This one goes here because it's somewhere in between 5 and 7 and 16 tiles, and this one goes into here because it's somewhere between 1 and 4 tiles. Then what happens is we then do the splat object shader after that, where each splat object shader looks at a bin and splats them into it basically copies them into the other buffer with some values changed so we can do the sorting. So the bit that I want the user who makes the shader to be able to do is they make their criteria. They figure out how they get the screen tile, and then from then on out, I need to make it so that there's a shade. There's a shader that can be called. Because you might do some occlusion culling here and reject ellipsoids, right? That you don't want to render. So you need to be able to. So what this code goes and does here is it basically figures out how many threads put their ellipsoids into the same bins, right? So it's just going over and um, yeah, it's going over all of the. It's using the first 5 threads of the thread group, and yeah, so yeah, so each thread atomically increments the object's count by 1, and then like the first threads. Oh right, this is a bug, isn't it? Shouldn't be of a wave, right? Yeah, I've got to be careful here. Want to say the first threads within a. They all could have been rejected though. Man, I gotta let all these things. Right, we gotta let them all carry on. No, you can't, Amadeus. Yeah, this is the problem with this one. I'm gonna have inactive threads. Um. Yeah, so somehow I've got to find because a whole wave could have just ended before here because they all could have been all the ellipsoids could have been behind the camera or out of the screen bounds, so therefore it wouldn't have come along here to this point. And then you are asking it to. So this is in the first wave in every single active in every single wave within the thread group, right? 256. But that's not going to work because that's going to duplicate it actually many times. So we've got to be super careful. This code won't scale. So if I take the first wave, then right. I think I found. So they atomically add a count into a bin. We could just get the one which got index 0. That's the one. Maybe you can't do it like that. The one that got index 0, say, could of one of the lowest bin, but you don't know which is the lowest bin that got anything in it. Um, so we could add another counter and get them all to fight. for it. Yeah, and then that one goes over all the bins and just calculates the eh. Right, we'll be making this code more general anyway. Right, I think what we can do is say also atomically add into this one at 0 of all the other thread groups. Is first is the not of that. Bit silly. But it means if we're the first thread within the thread group. So this one that got index 0 back. You then can do a for loop over all the bins. Extracts the bin count out from LDS and properly calculate the, we bump allocate into the next indices counter for that bin based on the number of objects that have been added across all the thread groups into that bin. Sorry, all the threads within the thread group for that bin. And then we just set it back into LDS for this base insert index. Great. After that first thread has gone over all of those, actually, since we're doing the first thread, why don't we just do the first 5? Done. But then if you've not done the first 5, you don't know. Yeah, I'm just trying to make this. Just trying to make this better, you see. So, right, I got ideas. So we can bring back this. So you want to know if this is so we'll call this the counter or base index finder index. Base indices atomic adder index into something. Yeah, so add 1 to each of those. The first bin count of those. So what you're saying is so how do we know which ones? I think we should just be able to load it. We'll have to do an atomic load. But maybe not. So you load it back. That's the number of sort of threads which are active. Active atomic adder threads. Because you might have less than 5 active, which is the number of bins. So you got to do this silly trick where you do a base bin index, then add your adder index. So this will be like 0 to 5. If you're the lucky one to do it. So you got to say if you're less than 5. Then, wait, why are we doing a for loop? Yeah. Yes. Then if this target bin index is still less than this here, Yup. Get the tiles count out and then yeah, that should be it. Alright, so that's the new code. Then after that, finally, you've got your base insert indices set up. And then this should... So we've done all of this just so we can avoid doing this 256 times on the same memory address globally. And then finally we get the insert index. So I think we can compress this all down into a function. And then the user can call that function, get an insert index back, and simply set this data out. That should be pretty alright. I just got to figure out how I'd make that. It's going to require some form of LDS memory, so we're going to have something like tile bin calculate insert index. I don't know what you pass in, but I think you pass in like the number of tiles that you want to bin into. And I think we should just be able to take all this code here, like that, and simply just replace it with a insert index of graphics tile bin tiles count. Yeah, I think that would be pretty ideal. So this sort of really weird thread group stuff just gets retained inside this shader here. Zig. Excuse me. I guess the bot just educated you on the language. Good bot. Good Fossa bot. But hey there, welcome Leo. Leoster, how are you doing, sir? How are you? If it was Zig, what you would be seeing is comp time T blah, and then probably const something, the code will be completely unreadable. That's what you'll be seeing. You won't be able to figure out what type your thing is without LSP, Oh yeah, U7. Yeah, or U31 because you can, right? And then like, yeah, hash import. Sorry, address import, you have files like index.zig, right? Yeah. Good times. Yep. I don't know what else you'd have, but yeah. Visual Studio and this syntax highlighting. Making my code unreadable, what are you doing? Right. So the problem with this function is one thing. It's missing this part here. Unfortunately, LDS memory, or thread group memory, whatever you want to call it, there's always 1,000 names to call the same thing in graphics programming. And there's also 1,000 things a name could mean, like the word buffer. What does that mean? You got like a depth buffer. It's actually a texture. So graphics programming. Anyway, we need to initialize it to 0 because it's uninitialized memory. But by the time we call this function, it is already too late. Or is it too late? No, because the first time we touch it is here. So maybe we can move this inside here, but got to be aware. Oh, but we also have to initialize the 0 one as well. Interesting. How are we going to do that? So we need the first thread. Oh, wait. So how are we going to figure out the first thread within a... There's literally no way to figure it out. We could atomically store from every single thread and everything, but I don't think that'll be a wise idea. We could say we could get the wave index and just wave thread index, and the first threads from the waves all do this. That would be a bit weird. But it's definitely, it's a solution, and we can always improve it later on. Thread index. So what I say here is like to do haven't thought of a better way to initialize this. So we could do it with two functions, but problem with doing it with two functions is it's error prone because the user will forget to call it in two places because the user's not thinking about how it works under the hood. To do haven't, what am I doing in English? Haven't thought of a better way to initialize this LDS memory. We only need one wave of a thread group to do this, but every wave will do it. But every wave is doing it right now. We also don't know what we also will have inactive threads at this point. I don't want to split it to two functions for usability reasons. But maybe we might have to do it like that if it poses a problem. So, right, we need to move this to the other tile binning code. So we find the tile bin. Up. Perfect. So this might, you want to be able to say object bins, and this will probably be called object bin. Wait, object bin. Alright, so I think this is pretty reasonable. There's probably another version of this we would have to write if we wanted to use it for a different setup. Right now this is one thread per object you're trying to bin. You might have multiple threads for some reason. I don't know why, but you might. Yeah, so we'll see how it rolls. Tile bin ellipsoids. So this shader What can we call it now? Tile bin. Tile bin, tile. What did I just call it? Name escapes me. Yeah, bin objects, bin, I guess. Bin objects, bin ellipsoids. I think that's what we'll call it. Alright, let's find all that. And then that's in graphic. Right. So let's launch that. We've now got this reusable API. The binning stuff. We might try and get the UI to be done with it as well. That'd be interesting, wouldn't it? When I mean threads mean local size. No, it depends. Yeah, it's very difficult to get the terminology. So yeah, thread. Yeah, so you have a by thread I mean yeah, when I say thread I'm meaning it's not the local when I say thread group that has a local size, right? And that thread group has a bunch of threads of local size. But you might launch many thread groups. Right, when I'm saying thread typically I'm just saying like within a shader. Yeah, I guess. Yeah, a thread within a thread group. That's what I mean. Even though it's technically like a SIMD lane. Hey VB Matrix, welcome, welcome. Hey there, Coffee Lover. Good to see you guys. Also, always call free just in case. Basically define. Huh? Why? Also, what? There's no parameter. No argument there. What's going on? Right, objects counts. Why is that one failing? Tell me more. SV. Uh, Right, we'll need a Okay. So we need an SV local index passed in. We're not gonna know. Wait, you could know if you're the first 5 of a wave. Yeah, but you wouldn't be able to know if you're the first 5 of a thread group without it doing cross. Yeah, okay, so you need to pass in your no, you need a wave prefix sum inside, that's how you do it. Right, yeah, that wouldn't have worked anyway. Right. Thread index. That's within a wave. So that'd be 0 to 31. So it's not within a thread group. Wave prefix sum U32. Prefix sum. Oh, for crying out loud, what did I do? Right, so prefix sum 1. That'll do it. Neat. So the only problem is if there's any high threads. Oh shoot. Yeah, there's a possibility that this will fail. Right, we're gonna have to split it into two functions. The problem is you could have all of your waves for the whole thread group of 256 might have, all of them might have less than 5 active threads within a wave, right? Of 32 threads. So that would then mean that this code would not run the whole way and zero initialize everything. So that's a problem. So we're going to have to say prepare right at the top. And you have to call this right at the start. And you also have to pass in the probably the dispatch group index and the dispatch local in. Wait, dispatch local index is all we need. Yeah. So you're saying if that is less than 5. Right, there's no way around it. It's got to be 2 function calls. Control barrier goes there. Alright, so you have to call it here before everything else. Warning. Must be called with all threads. Must be called from all threads of a thread group. Warning, all threads must call this and be active. Yeah, I'll do it. Cool, well, let's give it a run. Visual Studio. That bin prepare, is that another compute dispatch? No, that is just another function. So I've just put it, so the way my shader compiler works is when you got this compute, this just compiles down to this, and this is a special keyword that then parses this, and that means that changes the entry point. That changes this to be in an entry point. Changes the next function. It's part of a function prototype, basically. So these are not shaders, no. They're just utility functions. Oh, Visual Studio. Right, so hopefully that all works. Then we could probably try and bin those, bin the UI system. Because I think I've got a bug with the profiler I'm trying to write where it crashes, and I think it might be to do the tile binning process. It's good just to rewrite the code for that reason. But the main reason why I want to rewrite it is what's the reason why I want to rewrite it? Yeah, I want to test out this new general tile binning API, and also would like to remove code which basically does the same thing. And I think the tile binning code for the UI system, which is this UI, right? This is just the material editor. So this allows you to edit materials. I can't even see a material anymore because it's not being rendered there. Interesting. Weird that's lit differently. We're not seeing the Oh, this is actually changing the properties, isn't it? Yeah, it's not as rough. Yeah, so we need to actually get some models back into here. Okay, change the albedo and blah blah. There we go. Yeah, cool, cool, cool. But yeah, this UI system, it's another tile-based renderer, but for sign distance fields. So we might as well have some fun and try and get this API all tested out for that UI system. So we could go and do that quickly, or at least start it off. Or we can do some debug drawing stuff. Because the UI library does, or not library, the UI rendering code does actually have a bunch of, so we go to UI render. It has these where it debug draws the chunks. So chunks are just bigger tiles. Tiles live within chunks and cells live within tiles. So this debug draws those. We would just instead have a function which does this separately. And we probably want to draw a heat map. This is a draw command heat map. So again, we want a heat map for the number of items we're drawing on in each tile. So we can toggle this on and then just see, where's the most expensive tiles and that, and is our occlusion thing working well or something, right? Just, visualize some of the data a bit better. We should probably make those, and then a lot of these, well, these don't have to exist anymore when I port this one over. Or do you think that you can create a whole game engine using only compute shaders in a creative way? Yeah, that's the idea, because I think I could do it. Like, at the end of the day, it's just not rasterizing triangles, right? At the end of the day, under the hood from the triangle rasterization pipeline on AMD hardware at least, pixel shaders use compute units, which is what compute shaders give you access to. But obviously it's got a rasterizer which does the rasterization of the triangles. That's on a separate piece of hardware. So yeah, it's more than possible to make a renderer with compute only. People have done it in the past. It's not just me who's done it. People do it with like voxel ray tracers. But yeah, I'm doing it with like ellipsoids and things. People do it with particle rendering as well. They've done rendering a bunch of particles. So it's neither realm of possibility. I'll probably have some form of particle renderer later on, but not for a good while. Well, it might not be a particle renderer. It probably is the same ellipsoid thing, but with a special binner that goes after the main ellipsoid renderer, so we can occlusion call or something. Hey, it's all fine. How you doing? Right. Yeah, so maybe we'll quickly throw together that debug thing because it kind of completes this tile binning generalization. So tile bin start. So we can make another one called like tile bin enum graphics tile bin debug. Yeah, you probably want to put this in the shader. So this is probably going to be, it's a tile bin show or debug. We could probably do one at a time, right? One would be tiles. Debug tiles. So you're just sort of viewing them. The other one is a heat map based on how many objects you got in there. And I guess we'll do a count. You can only do one at a time, right? It just sort of changes what the shader does. So this would be inside some kind of like shared place. There's a tile binning section somewhere. Oh, yeah. So, what performance penalty is it? Well, it's hard to really say because I've never really tested it. There is definitely, if you're going to be rendering using compute, you've got to be rendering something that is not triangles. Because if not, you might as well just use the hardware and get the performance. Although you might be able to do something like what Nanite does, where you render sub-pixel triangles, right? But I don't know how that's going to be, you know, if you render like really small triangles, you're going to beat what the hardware does because the hardware's not designed for that. But I don't know how well that actually is in practice, right? So you could do like a voxel renderer, you could do some other kind of basic shape. You could do sign distance fields, another one. Um, but they all have their own kind of problems, right? Triangles have their own problems, ellipsoids have their own problems, voxels have their own problems. You just got to know what those are and accept those are the issues of this type of rendering, and either you get around those problems or you just plainly accept them, and that's the way um your games have those sort of limitations. Um, so in terms of performance as well, is you're not gonna have a kind of preset of guidelines which you can follow in terms of like everyone knows. Well, if you do some googling around, people can help you and say, how you render triangles fast is you do these things, right? And there's these sort of tricks to get around these problems. Whenever you do some kind of different primitive, the problem space is different. So when you want to try and optimize it, you've really got to optimize it manually using compute shaders. I'm doing like these tile binning things, and um, when I had an ellipsoid which covered the whole screen, that's a new problem I've got to solve because the way I was binning those into screen tiles was in one thread across 2 dimensions of screen, and you have tons of inactive lanes. It's horribly so. It's what one millisecond to bin one ellipsoid in that case. It was really slow. But I optimized it, increased it by 62 times or decreased it by 62 times. So now it's acceptable. So there's all this sort of hand optimization you have to do that you wouldn't have had to have done. But with the traditional approach. So, but you know, there is other people that have done similar sort of stuff like this out there. So I didn't make all this up, right? I just did a ton of research and found different ideas, and also just tested them out because it was fun and for learning purposes too. So I've done tile-based binning, Foxhole binning, um, BVH binning. Um, I think that's it so far, but I've done them a few times, and I've done yeah. Um, so let's just say the complexity goes from being this sort of very state API where you manage these sort of state objects into being manual code that you do with compute shaders. That's where the complexity goes. But it's something that you can control more of though. SDF into point clouds. Yeah, you can do stuff like that. It's something unique, something a bit more unique as well. Obviously, people have done that in the past, but you know, it's not the main bread and butter of rendering, isn't it? Um, have you seen Programmer Lynn's work by any chance? Yes. Yeah, so his yeah, it was Lynn Jake Lynn, wasn't it, on YouTube, where he'd done this sort of voxel game where it had like physics and it looked pretty cool and like the water looked good and the physics looks good and the voxels were like teeny tiny. And yeah, I don't know why that thing's not seen a release yet. So all I can tell you is I have some kind of vague inside tiny piece of inside knowledge. So I think it was, you know, the Handmade Seattle conference. So I think it was not this year's, obviously, maybe last year's or the years before. Time has gone very weird, obviously, lately over the past so many years. So struggle to remember. But there was that. Oh, I'll be able to tell you exactly. So the person who did, um, yeah, this Davis Morley guy. There was last year's one. He was talking about how you could this was for his hobby project. I don't know if this is how the renderer works for Jake Lynn's thing, because I imagine it's got some ray tracer. This was talking about rasterizing them, but it kind of like ends up probably putting a ray through the rasterized box or something in the pixel shader. But anyway, this guy here, he actually works for Voxely, which is the Jake Lynn's um, company. So he's actually working on whatever project he's working on. So I think they're probably working on it still, but it's just game development and being indies, obviously. Like, and you're trying to make something. You know, making a game these days, you got to do like all these things to make people happy. So I think maybe it's just still in the works. So you know, his prob or they, because it's multiple people, are probably just figuring out what. Um, yeah, they're probably just figuring out the game and how they're going to get it to the finish line. I have no idea. Yeah, but I guess you can try and stalk those people and figure out if they're still working there. You know, there's LinkedIn, there's social media where people talk about stuff and put in their bio what company they're working at. So you can figure stuff out. So we just want to render to the screen. So debug, render, debug, draw. Let's call it debug. So this is going to render to the screen. I've got to find some kind of texture. Output, there we go. Jobs are good. And so, no. Didn't copy it in the end. Right out loud, this. I need to get back on Linux. Right. So this is the push constants. Right, so where are we going? So I want to be able to make one which is called, don't do this. Debug. And you pass in that graphics tile bin debug. These are the debug options. Well, debug mode. We should probably call it mode. Mode makes it seem like an enum. And we'll have a none. Alright. So rightio. So what we're going to do is launch a compute shader. So I just got to find output somewhere along here. Grab this, I guess. It's just the ellipsoid ray tracer that happens after the tile binning. I've just copied it. We've got a bunch of different options for like anti-aliasing and stuff. Super sampled, MSA, and RTAA. The last one I made up. So tile bin debug. Output right only to that. Good. And then we pass in the enum for debug mode into the shader. Neat. We might have to pass in the tile ranges actually, because if I debug do a heat map, I need to get access to the ranges. So yeah, I'm going to need that. Carbon debug. We need the screen dimensions or the scene dims. Yeah, those are probably going to come from. Yeah, we could pass them in, but really they could be in a global somewhere. I'll pass them in for now. No, let's just do it right the first time. But really, we should also make sure that we set graphics scene dims to scene dims, because we're probably going to have this stuff split into actual functions anyway, and passing stuff around is just annoying. So we'll make these. All those again, they're U32s. Times 2, so surface dims and scene dims, because we can have a bit of UI where it renders the scene inside the UI. So yeah, inside the bin debug, we can now refer to ggfx dot this. Cool, so that's going to launch that. I do think though we are going to want access to the ranges, so we will actually want this in the end as read only. So ranges is this one here, read only. That's just going to launch that full screen. So we just need to find the shaders. We do the find ranges, and all we want to do is copy this shader. I think, yeah, where's the render ellipsoids, or ellipsoids render ellipsoids tile. Ellipsoid ray trace, so this is it. I want to do this swizzle thing. Oh yeah. It could be a tile dim as well. You need to access the tile dim. That needs to be passed in from somewhere. Right, I need these things. This is what I need. Alright, call it debug. So do this more on Swizzle such that every 4 threads does a 2x2 on the screen. So it behaves like a pixel shader. So you can use quad intrinsics. And also it's more optimized because AMD says you should organize your threads like that if you're going to be, I think it's storing out to textures, but it might be reading as well, I forget. Let's get the store texture thing ready. Rest gets deleted. Cool. So, right. Next thing to do is figure out the mode we're in. So we switch on the BC debug mode, and this will decide the final color. So let's just say the final color is 0 in every channel, and maybe you only write out if you have something in the alpha. Cool. So because that could be a feature, because you might not have anything in the range, for instance, so therefore there's no point drawing those things. Maybe yeah, we can have a look. So I'm trying to look at there. Don't crash. It's gonna crash, isn't it? Yeah, so in the internal shared. Yes, these are the boys and girls that we want. So cool. So these will do nothing. The tile is going to make a color based on the tile index. So I think we can get the tile index. I think I got a GPU nice color. We can always improve this function now that we've got those that OKLCH code in the code base, because we made the OKLCH color picker, which is quite nice. You pass in that, and then we probably want to say unpack. I think it returns a U32. That's cool. The other one's the heat map. So the heat map wants to take the tile range, and we need to. So I think we had a bit of code which there was this turbo color map. I think I want to try that. Let's try that. Yeah, so it gets redder. Yeah. So it's blue. It's it's cold to hot, isn't it? So so it is between. I think it's between 0 and 1. Yeah. There's a special color for infinity, apparently. Yeah, I just bought it from GLSL. There's some shader code online. I think it was in some shader toy. But yeah, so we should be able to use this and pass in some kind of range. So let's say the biggest range is 64. So we'll just say what is the max, what is deemed as a lot. So do 64 divided by range dot end take range dot start. And then with that, we should have our lovely debug shader. Will help us, be able to figure out some things. So we need to pass the tile. It's in the future we can use this to figure out like where we can use it just to see the tiles, so I can demonstrate how big the tiles are and things like this. But also see a heat map, which could help tell us how well our occlusion culling works. We don't have that yet, but we're going to need it in the future. So we need these two things passed in. This could probably come up via the push constants. So we have to, unfortunately, they're going to have to come up through the push constants. So we need to pass some extra data into the functions. So tile dim, how big is a tile? And also tile grid dim, grid width, I guess. Don't do this. Oh, Visual Studio. It opens up the same file twice, one with backslashes, one with forward slashes. It's silly. Might be something to do with the compiler running and then given different. I don't know, I didn't experience this before. There we go. Right, good. Cool, so from the CPU side, in that debug one, unfortunately, we've got to have some things passed in. Yeah, so graphics, tile. Let's debug the tiles to see those in action. And the ellipsoid tile dim. There'll be a tile width. Sorry, tile dim, and then a tile grid width. Neat. Yes, that should run now. Give that a go. Did I put it in the wrong one? I didn't copy this over, wasn't it? Using the wrong. Right. Right, did I not rename that then? I don't think I renamed this from... It's next to the ray tracer. That's not the general tile binning though, so this needs to move. Where's that ray tracer? Next to here. Yep. Cool. Interesting. It was useful it being 3D so I could make a texture without having to construct or up the number of components in the vector, right? I could, yeah. Right. Conflicting types. Radio, no biggie. I can just go to there, and that's one of the great things about C and not C++. You don't have overload, so it can catch errors like that. Incorrect, like headers basically. This is pretty cool. Right, so we're not debug. The debug drawing is happening before this is happening, so but it's fine because we've got the texture viewer, and the texture viewer can open up the scene texture. Here it is. We can see like, hey, we clear it, we debug draw the tiles. Here are the tiles, right? They're 8x8 pixels in size, and voila. So then afterwards we ray trace it, yeah. So we could just right, and the other. So what's interesting is maybe we could just draw to it before, and then just always be able to access it. Is interesting. So the other type of one we want to do is actually just is the heat map. So have a look at that. We're not going to really see much though. Oh crap, did I not? No, I checked into turbo. Yeah, yes, it should be fine. Anyway, here's the these are just screenshots I've done in the past. Right, so there's the heat map. Kind of red looking. We can't really see it. Purple's infinity. Because we did a divide by 0, didn't we? So that got made infinity. Yeah. Right. Cool. So at least we're seeing some kind of thing. So red. Wait, where's it red? Good question. Where's it red? Because it should be the turbo thing. And turbo, from my understanding, was red was blue to oh, maybe mine's like this one where it's red is near. Right, then as it gets far away, it's right. I don't know. It's pretty cool. Yeah, it should really get some proper ones. Or get some other ones maybe. I have a proper look at it. Cool. Yeah, we can't really test it more than this because we don't really have model instances yet where we can look around the scene. So that's like a tile heat map, but that's not actually like, yeah. So that's just how populated the tiles. Another one we might want to look at is how expensive the ray tracing is, right? How many ray, you know, tests are there per pixel? That's another thing we could add as some form of heat map. But yeah, interesting. Right, so that was pretty cool. Well, at least got the optimization done today. So the next things that we want to do is, so I think if we were to work on this sort of UI tile binning thing, it's just going to take away from actually making progress to get back to the editor. Right, I want to get back to the editor as quick as possible. I really wanted to spend only December on this rendering side of things, and there's still some more things I want to do. So the next thing, let's say the next thing we do is get the model instances working. So we have a way to render ellipsoids now. They're anti-aliased, which is great. We can render two of them. They're tile binned. Let's get a way to group them up as a model, and let's get a way to create a bunch of instances of a model and have that in world, and bring back that old, very simple test scene that we had, which didn't have the most stuff there, but it was a test scene nevertheless. Bring that back because the code is still there, and see what the performance is like compared to what it was before. Yeah, actually we can't really tell because this is kind of above 1080p and on a different card, but maybe it's kind of similar. Yeah. It's all cellophane. Hey, random question: is computing a cosine for ray tracing something that happens often? What do you mean by computing a cosine? Um, I don't know what part of it you... Do you mean calculating the ray direction or something? I think that one uses tan. I don't remember. Um, yeah, I think you use... I forget. Let's try and find the code that I use. Ray direction for pixel. The passing field of view. Yes, this is one I use. I could probably, pre-calculate some of this information. But yeah, field of view, the dimensions of the buffer and the pixel coordinate. So you get the half dims of the thing you're gonna render to. Subtract that from the pixel coord, so that means pixel coord is relative from the middle of the screen. Right, so there's your XY offset from the center of the screen. You obviously offset pixel coord, so the pixel coord is in the center of the pixel. Then half of field of view radians, tan, is the size from memory. It's two things. It's your sort of texture is going to sit here. Like technically it could sit like the eye has it behind, right? In real life, your eye works sort of this way and the image flips, right? And the lens is here. But then I don't think we do that in rendering. Maybe it's just simpler, but the camera position is there. And so this is origin 00 in view space. And that's your ray going through the center of the screen. So that distance there to the near plane is the field of view, so how wide these things are. half of that right, which is the field of view for the y-axis, um, and then throw that into tan. Yeah, 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 yeah. And then that will get you that, but it also gets you the height as well. So gets you the height. See, that's the distance you place it away. And then you basically just normalize that vector. So yeah, I don't know why. There might be some method to do it with cosine. I don't know. Maybe. It's possible. That's is what I understand from it. Um, yeah, so I guess you say it's tan because this is like technically like a triangle, and you know, you've got the angle, right, of that or something, and because you have the angle, and it's unit length or something like this, it's just tan. I don't know, something like that. Yeah, maths. I don't know exactly what it is, but it's something along those lines. Um, right. So the next stream will be on Sunday, about 4 hours ago Sunday. But I'm taking a Christmas break on. So usually the stream would be 24th, so the Tuesday and the Thursday. So 24th and 26th, I'll be taking a break. So last stream before Christmas will be 22nd, and then I'll be back on the 29th. So it'll be a whole week off. You know, I might be doing some programming in here, but because I'm off work, but I'll probably just be spending time with my son. So we'll see. But I might work on getting the tile binning working for the UI. Maybe setting up my PC for Linux again. You know, I find something to do. That's kind of a bit different to working on. Right, so I'll get that code up on the repo for you guys. Thank you for everyone who supported the channel. Appreciate it. Let's find someone to raid. I have an alternative trick functions that might speed it up. I can show you an example, but okay, that's cool. Now, I don't think that's the bottleneck. Like, I could pre-calculate some of it. It's not that expensive. But if I do it a lot, it might be beneficial. I think I might do it in one of the MSAA or the super sample. I think it's the MSAA shader, or maybe I changed it. Yeah, something like that. Right. I might just bail if I can't find anyone. Yeah, right. Cool. I'm just gonna bail. Right, have a good evening, guys. I'll see you on Sunday.